Hi Indradeep, Mokshana, Shivraj, Saiti, hello Kabilesh, welcome aboard. Welcome to We and Light, my lovely warriors. Welcome to the IDOC series. And IDOC series is for all the NEET aspirants who want to crack the NEET 2022 exam. And we have divided the entire portion into blocks, very important blocks. When you do these blocks, then you will realize where your weakness lies, where your strength lies, and accordingly you can still work in the last few days for your NEET 2022 exam. So what I have done is, in this block today, we are touching upon the entire modern physics that includes photons, de Broglie, dual nature, then you also have, the atomic structure, then you also have the nucleus part, and then semiconductors as well, and electronic devices, logic gates. So all these parts, questions we are going to revise quickly according to, depending on the question. I will be also touching upon whichever concept is there, or if some formula is there, or when to use it, when not to use it, all the tricks associated with the application, everything will be done in this lecture. Okay, so let's begin. Yep. How can only these two sessions, bacha? There are more sessions, Vaman. This is just the second block. There is third block, then there is fourth block, and then there is also the short series as well. Okay, so get ready, my warriors. Let's begin with the class. And those of you who do not know me, my name is Shreyas. I'm the physics master teacher out here, training kids for more than 10 years and awesome results like every time. I'm hoping this time too you are going to make me proud this year as well. So it's just a matter of 2 weeks. We have to work very hard. So concentrate, focus, and also make sure your rough sheet is with you so that you solve the problem whenever I show you the question. Okay, PDF will be available later on in the Telegram channel. You want to know more about me? That's my Instagram handle where you can contact me. So let's begin with the class, and I hope you have smashed the like button as well as hit the subscribe button as well. So let's begin with the class, guys. Okay, the duration of the class will be 1.5 hours or 2 hours max. Okay, somewhere around that. Good evening, Tanu. Hi, Ghost Rider. Thank you for all the love from Tamil Nadu, guys. I was going through all your comments in the previous session, and thank you for all those lovely comments which you have given. This was the first block where we did the entire mechanics, so you can open that as well. In case you have missed that class, make sure you watch that lecture as well. And thank you guys for all the love. Oh my god, thank you for all the love from Tamil Nadu and every part of the country. I'm pretty sure you guys have been there. Thank you so much, guys, for all the comments. AA, Sri Surya, Elizavardhan, Usharani, Saurav, Harini, Kushi, Sushila, Ahari, Nitya, G Shruti, Jia, Marthina. Thank you so much, guys. It means a lot. All the lovely things that you write for me, it really makes my day. That's all I come here for. So let's begin with the class, and we'll start with the first unit of today's session, and that is basically atoms and photoelectric effect and dual nature. So these are the most important topics on which questions can be asked in the NEET exam based on my previous year analysis, whatever I have done. So things like dual nature of light. So you know that light has particle behavior, so that is photons, as well as wave nature, that is electromagnetic waves. Same way, when particles have obviously momentum, which is particle nature, and wave nature, that wave nature is called de Broglie wavelength. So you should know how to convert from particle to wave, wave to particle, and both for light as well as for regular particles like protons, electrons, etc. In photons and its properties, please go through all the properties of the photons, like the photon travels at the speed of light, the energy of the photon is this. When a photon is absorbed, then you will see that the electron jumps from one orbit to the other orbit. All these properties, the momentum of the photon is given by h by lambda. All those properties you should know. It's there in H.C. Verma or NCERT or whichever theory book you might be following. Then obviously the Thomson's model, Rutherford model, the shortcomings, the advantages. Every model you should know, and also what was good in it, what was bad in it. Bohr's model postulates all these things you should know. And also obviously the hydrogen spectrum, the Rydberg's formula for the wavelength, the energy formula, speed formula, radius formula for the orbits. All these things you should know. Okay, so are you ready for the start of the session? I'm pretty sure I can see that there are a lot of loves out there, a lot of hearts out there, purple, red, pink, yellow things. So let me ask you a quick question. Guys, let's see how many of you are active. I'm just going to push you up. Little bit of warm up before we start. Come on, guys. The radius of an electron in a Bohr's orbit is proportional to n raised to what? It's proportional to n raised to what? Thank you, Sam Kumar Jiju Varpu. Thank you. I'm hoping that I'm pronouncing your name properly. Yes, this block will help you, Rini, not for 120 marks. Sorry, bacha, it will not help you for 120 marks. It will help you for 150 marks at least. Okay, so not 120, guys. I'm hoping for more. All right, Rini, it's not 120, it's 150. 1/3 to radius. Radius is proportional to z square by n square, z by n, n square by z. It is proportional to n square. Velocity was z by n and energy was z square by n square. So it is n square, guys. It's n square. Okay, very good, very good. Let's see if you can do this question. Imagine if I increase the intensity of light on a photoelectric material. If I increase the intensity of light on the photoelectric material, then the current will dash. Will it increase or decrease? And the stopping potential will dash, increase or decrease. Come on, let's see how many of you can do this. 2 is the power, Jato, Sai Charan. 2 is the power. So radius is proportional to n square. So the power of n is 2. So that's what I had asked. Yes, Pavitra, you can watch it for GA as well. Definitely. Study material, I would definitely love to meet all of you someday when your exams are over. Just come down to office. Definitely Bangalore. Okay, so think about it. When intensity of the light increases, what happens exactly? Intensity of light increases on a photoelectric material means more photons will collide. More photons will collide means more electrons will eject. More electrons will eject means more current will come. So current will increase. But will the kinetic energy of the electrons change? No. When intensity goes up, the number of photons increases. But energy of photon is only dependent on its wavelength or frequency. So frequency has not changed, wavelength has not changed. So energy of the photon has not changed. So the energy of the electron also won't change. So it will be the same thing. Is that clear? Everybody, stopping potential, no change. Current, yes, it will increase. Very good, guys. Awesomeness. Let's see if we can solve the next part, which I'm going to ask you guys. When I mean the last line of Paschen series, what transition to what transition am I referring to? From what to what transition am I actually referring to? 2 years is more than enough, Miru, for JEE Advance? Yes, anything 2 years is very good. You don't have to study for more than 2 years, bacha. It's rightly decided. For Paschen series, from what to what will the electron transit to emit that particular, photon? Paschen. Hello Khushi, hello Deepu, nice to see you back, guys. And I read all your comments. Thank you so much. Okay, so Gokul saying 3 to infinity. Somebody, Alina is saying just 3. I need both the orbits, guys. Both the orbits. Somebody saying 1 to 3, somebody saying 3. The last line of Paschen series, what to what transition will occur? Think carefully. There are multiple series, so you would have to remember it in order. Lyman, Balmer, Paschen, right? P-Fund, bracket and all is there. But I'm talking about Lyman, Balmer, Paschen. Paschen is the third. So 1, 2, 3. So yes, it should come to the third orbit. The last line will come from infinity to n is equal to 3, not 3 to infinity. Guys, you got it wrong. Many of you are saying 3 to infinity. Nope. So when that wavelength will come out, the electron will come from infinity to 3, then the photon will be emitted, the wavelength will be emitted. 3 to infinity, wavelength will be absorbed, light will be absorbed, then the electron jumps. If the electron jumps from high to low, then the photon is emitted. So answer will be infinity to 3. If there are two options, then you will be marking infinity to 3, not 3 to infinity. Understood, my warriors? So these are the kind of mistakes you can make. Hi Niveda, hello Hare Krishna, hello everyone, bacha. Shall we proceed? Okay, so I have some awesome super duper questions for all of you. Here is the first question coming up on your screen right away. Come on. Buck up guys, and do not forget to smash the like button if you have joined in right now, or if you have forgotten to smash it, because that's the only thing I need. Okay, your support, your love, that's all I ask you. And obviously your marks, I want your marks. If you don't score, I will feel very bad, remember that, because I'm working really hard for all of you. So one electron and one proton have equal energies, then the ratio of the associated de Broglie wavelength will be what is to what? Interesting question. Let's see how many of you can do this. Kritika, I have already done 0 to hero and 0 to superhero series for JEE as well, so you can watch that, bacha. So a lot of NEET students were asking for them, and since we are now a NEET plus JEE channel, that's why we are doing it for this. But Kritika, let me tell you, if you're a JEE student, you can watch this. Okay, the mains level is very much similar to NEET level, just that the pattern, the number of questions is different, that's all. Difficulty wise, NEET is almost similar to JEE, slightly easier. Obviously NEET is slightly easier because number of questions are more, but other than that you can watch it. Okay, all right. Yes, Deepthi Mohan Rao, you can definitely watch it. Okay, yes, Rini Poloni, you can watch 0 to hero level questions plus iBlock, and not just watching, you have to practice, Rini. Don't just watch, bacha. You can definitely get 150 marks, I am assuring you. Okay, so let's try to solve the question, guys. And here it is. This is how we're going to do it. The electron and proton have equal energies, then the ratio of the associated de Broglie wavelength. So lambda of the electron upon lambda of the proton, okay, is going to be given by inversely proportional to the momentum. Lambda is h by p. Lambda is nothing but h divided by p. So it will be nothing but the momentum of proton upon momentum of electron. It's inversely related. And now momentum is nothing but root of 2 times of mass into the kinetic energy. That's the formula. So this is nothing but root of 2 times mass of proton into kinetic energy of proton upon root of 2 times mass of electron into kinetic energy of electron. It is clearly mentioned they have equal energies. So kinetic energies are same. 2 cancels. So it will be nothing but root of mass of proton by mass of electron. We know the proton's mass is 1,836 times the mass of electron. Hence, the answer should be B. Very good. Thank you guys. Very good. Awesome. Hello Tejaswini. Hello everyone. Hello Buster. Hello. Okay, so guys, the entire PDF will be available on the Telegram channel. The link of the Telegram channel is there in the description box. You will not be able to search it on Telegram. It's a private channel. So you can join the private channel. It's an exclusive channel for all the members, where all the PDFs, homework solutions, updates, notifications, everything you will get it over there. Okay, so make sure you join it. It's there in the description box below. Next question. Hello Priya, welcome. Let's do this. It's a graphical based question. Which of the following figure represents variation of particles' momentum and the associated de Broglie wavelength? Now this, everybody should get it. I want everybody to put the answer in the chat box. You cannot go wrong with this. Okay. So if you are getting 80 to 90 marks in mock test physics, Kirtika, then I would suggest 2 things, bacha. Just do 2 things. Number 1, yes, watch this block series. That will help you understand what are your weak points, number 1. Number 2, please download and solve all the mock tests which are there in the test series. There is a link in the description box. The test series is for just 999 rupees. There are some, I don't know, I think around 20 mock tests at least. So 20 mock tests for just NEET. Give these 20 mock tests and attend these classes. Trust me, your rank will improve. Trust me, your marks will improve in physics. Okay, just solve problems. Don't read theory from NCERT. It's not the time to just read theory. It's the time to act. Okay, so there is a link, guys, in the description box for others also. Yes, there is a exclusive test series for NEET. Just go ahead. It's for 999 rupees. There's 50% off when you use the coupon code SHHPRO, of course. Yep, the correct answer is option D. Some of you are saying C and B. I'm not sure why you guys said that. Well, see guys, the wavelength is nothing but h by p. So basically P is inversely proportional to the wavelength. So this is the only way this can happen. It has to be a curved line. C can't be the graph because this is a straight line. This is a straight line. Whenever things are inversely proportional, the graph has to be a curved. It's actually a rectangular hyperbola, but let's not get into that. Next question coming up on your screen. Okay, so here we have the de Broglie wavelength of a photon and a proton are proportional to the energy e raised to x, where x for each one of them will be how much? Okay, I have not put up the options. I could have put up the options, but you only tell me and let me know in the chat box what should be the correct value of x for photon and proton. See, the energy of a photon is nothing but hc by lambda. Correct? The energy of a photon is nothing but hc by lambda. So just rearrange this. For a photon, right? So you are just going to get lambda is equal to hc by energy of that photon. So this is the lambda of the photon. So you can see lambda of the photon is directly proportional to the energy whole raised to -1. So the answer will be -1. This is -1 for a photon. So the value of x will be -1. Okay. No, some of you are saying 1, guys. No, it is not 1. It is -1. Be careful. It is inversely proportional. Just see where you made a mistake. You might have definitely made a mistake somewhere. Just check that out. Okay. Just see. Okay. Now moving on to the next one. That is the proton. So for a proton, what are you going to do? Think lambda for a proton. I can write it as h by the momentum of that proton, and the momentum of the proton is root of 2 times mass times energy of that proton. So you can see lambda of the proton is inversely proportional to root of that energy of that proton. So it is directly proportional to energy of the proton raised to -12. So hence the answer is -12. So it's -12 and -1. Okay. Kritika 24. There is an entire formula revision present on this channel. I'll show it to you in a bit. But this is a beautiful question where you have both the concepts, light as well as particles. Light's particle is photon, proton is already a particle, and how their energies are calculated in a completely different manner. So whenever it is light, you use this kind of formulas. Whenever it is particles like protons, matter, then you use these formulas. So those of you who are wondering where to see my entire formula revision, guys, so all you need to do is basically just go to playlist tab over here. So on our channel only everything is there. I'm pretty sure some of you know it by now. So there is Zero to Hero Superhero Physics series, one shots of all the class, many chapters are there, all the high weightage. Then you also have Zero to Hero Physics. Okay, this is the last year session, but trust me, it is wonderful for one shots of every chapter. And there is also this formula revision. Do you see that? Complete formula revision. Just say click full playlist. See this complete physics formula revision. Now this is not just for J, this is also for NEET. Okay, so don't get scared just because J is written. It will not change, guys. Okay. Shall we go ahead, guys? Shall we go ahead? Thank you, Ritik. My God, why are you giving me muddy hearts? Bacha, what happened? Everything fine? Okay, it's not visible because I have a dark mode activated. All right, guys. So let's move on to the next one. Thank you, Bacha Anupama, for all the love from Kerala. Thank you so much. Okay, so here is the next question. The ultraviolet light of wavelength this much is used in an experiment on photoelectric effect with lithium cathode. More than one option is correct. Don't worry about more than one option. Sometimes in NEET, they give you multiple options correct, but in a different way. And they will be like, option A and B are correct, option or 1 and 2 are correct, 2 and 3 are correct, 1, 2, 3 are correct, none of them are correct. This is the way they give you multiple correct. Okay, this is the way they give you multiple correct. So think about it and let me know what should be the correct one over here. Okay, so come on, guys. Let's see how many of you can get this. Ultraviolet light of wavelength this much is used in an experiment. So work function is also given. Maximum kinetic energy and stopping potential is asked. I think we should use the photoelectric equation, which is energy of the photon is the work function plus the kinetic energy. This is your standard photoelectric equation. Energy of the photon is 1240 divided by lambda, which is in nanometers. Now this lambda is given to be nothing but 310, correct, in nanometers. This has to be in nanometers. And this work function is 2.5. Whatever answer you get is in electron volt, is also 2.5 electron volt plus the kinetic energy. Now 1240 by 31, that's going to be 4 electron volt is equal to 2.5 electron volt plus the kinetic energy. So the kinetic energy will be 4 minus 2.5, that is going to be 1.5 electron volt. So 1.5 electron volt is there over here. Now kinetic energy is nothing but electron times stopping potential. So hence the stopping potential will be 1.5 volts, which is right over here. So hence option A and B will be correct. Guys, either C, D will be correct together or A and B will be correct together. Okay, you can't have B and C or A and D. Both of them will come together. Remember, kinetic energy is E times of Vs. This is the formula, maximum kinetic energy. Correct, Rohit, very good. Gokul, no, A and D will not be correct. Very good, Shivani, very good, Aswin. Bala Mukundam, very good, Bacha. Mohammad Asif, 30K is a little bit higher side. I doubt, Bacha. For computer science in VIT EEE, no. You need little bit higher ranks over there. Okay, let's move on to the next question. So, if you just do modern physics and electronics, can you get 40 plus? No. Just using that, Chandana, you will not get it. You will need to do little bit more than that. Okay. So you'll have to do maybe something more like mechanics plus modern physics. Then you can expect it. 40 marks is a lot. That's like, you know, you are asking 10 questions just from this unit. That's a lot. You can expect some 6 to 7 questions, but not 10 questions. 10 is on the higher side. Even if it comes, it will be a rare occurrence. Light's frequency is given, threshold frequency is given. Maximum speed in the first case is V1. When the another frequency is used, the speed is different. The ratio of V1 and V2 is asked. Okay, so let's try this question. First part, the frequency is this much. Threshold frequency is obviously going to be same. The speed of light is V1. No, sorry, the speed of electron is V1. So using our photoelectric equation, which is nothing but energy of photon is work function plus the kinetic energy. So energy of the photon is h into 2 nu naught is equal to work function is h nu naught. Kinetic energy, I can just say it is half m v1 square. So this is just going to be half m v1 square is equal to h2 nu naught minus h nu naught is just going to be h nu naught. That's it. Now for the second part, when the frequency of the incident light is 5 v naught, then the speed is v2. Then the speed is v2. That's what is given. Okay, so let's try to figure that out as well. So when the frequency of the light is it's 5 nu naught. So energy will be h into 5 nu naught. Work function is h nu naught. Kinetic energy will be half m v2 square. Shift it, you are just going to get half m v2 square is nothing but 4 times h nu naught. Now once I get this, read the question. V1 by V2's ratio is asked. So the question is basically, what is the ratio of V1 and V2? So V1 by V2 will be V1 by V2. So to find that, I will divide these two. So to find this out, I will just divide these two. What will I get? V1 square by V2 square, because half m cancels, will be h nu naught cancels. So it will be 1 by 4. Hence V1 by V2, how much will that be? It will be 1 by 2. Correct? So from this, I will get this. So 1:2 is the answer. Very good. Okay, I hope this is fine, my warriors. Beautiful question, standard question. These are very common. I saw these kind of patterns in the previous years as well as in the recent JEE papers as well. So guys, don't think that JEE papers is not for NEET students. In fact, you can get some clues and hints, because remember, NTA is making everything. It's not a NEET is separate, JEE is separate. NTA is the main authority making all the papers. So you can see what they are liking, what they are not liking by looking at JEE mains papers also. Okay, and the same relationship was observed last year as well and before that as well, where they have followed similar trends. Like the trend of modern physics is increasing. You can see that. Peculiar questions, magnetic field, they always end up asking questions where there is circular motion problem or some particle is thrown in magnetic field, find the force on it. Standard question every time they have been asking. So that is what you need to look for. Look at the trends. Next question. 20K might not get you great branches, but the top branches, sorry, but maybe you will get some decent branch somewhere. Okay, so photons with energy this much incident on cathode of a photoelectric cell, the maximum energy is 2. When photons of energy this much is incident, then the stopping potential will be how much? Interesting. It's just twisted a little bit. Let's try this out. Photons of energy this much. Again, photoelectric equation. Energy of photon is work function plus E times of Vs, or the kinetic energy. So the energy of the photon is 5 electron volt. It's 5 electron volt. The work function not given, but what is given is the maximum energy of the photoelectron, which is EVS, which is also the kinetic energy. So that was given, that is given to be 2 electron volt. From this you get the value of phi as 3 electron volt. So this is the value of phi which I got. Okay, I'll keep it aside. Now look at the second piece of information. When photons of energy this much are incident, then to make sure none of the electrons reach on the other side, obviously you have to apply stopping potential. So the question is, what is the stopping potential in the second case? So well, let's again use this same equation and see what happens. So photons energy is 6 electron volt is equal to work function will be the same, which is 3e, plus the kinetic energy. So the kinetic energy is going to be 3 electron volt. So this 3 will be your stopping potential. But keep in mind, stopping potential is to stop the electrons. So it's always applied in reverse. So this is always in reverse. So the reverse voltage that you will apply will be minus 3 volts. Hence the answer will be not plus 3, minus 3. So both the options are there. Many students will get confused. But remember, minus is there because it's a stopping potential. It's always applied in reverse voltage. Okay, so that's what is asked. Sai Lakshmi, we are doing modern physics and we are doing right now photons, photoelectric effect, etc. Okay, shall we go ahead? Okay, let's have a look at it. Next question. A 5 watt source emits monochromatic light of this much wavelength. When it is placed this much meters away, it liberates photoelectrons of current 16 milliamperes. The same source is moved away to 1 meter. Then the new photocurrent will be how much? Okay, let's try to do this. Very good, Samia. Arnav, just put up a comment or contact me on my Instagram handle, bacha. That's captain_Shreyas, or leave a comment. I'll definitely get back to you. Let's concentrate on the class right now. So first of all, realize what is happening. There is a source, okay, and it is kept at some distance. Okay, it is kept at some distance from some photoelectric cell over here. So there is some photoelectric cell over here, and on that photoelectric cell, this light is incident, and you are seeing that there is some current which is flowing in the circuit. So the question is, what will happen if you move the distance or change the distance, to a distance of 1 meter? Then what will be the new current in that photoelectric effect circuit? So here is what I will think. When you change the distance, what happens is the intensity of light gets affected, correct? When intensity of light gets affected, the number of photons falling changes, so the current gets affected. And more the intensity, more the current, less the intensity, less the current. So intensity proportional to current. So now I get the idea. So what I will say is that the current is directly proportional to intensity, but intensity is directly proportional to the inversely proportional to the square of the distance. This is very important. Inversely proportional to the square of the distance. This is very, very important. That's it. Hence, now you will get the idea that therefore current is proportional to intensity. Intensity is proportional to 1 by d square. So current is proportional to 1 by d square. Now observe what is happening. Initially the current was 16. What is the final current? So final current by initial current will be initial distance by final distance whole square. So final current is something I don't know. Initial current was 16 milliamperes. This is D1. D1 was nothing but how much? It was 0.5 meters away. Next time it is at a distance of 1 meter away. This thing whole square. So 0.5 is nothing but half. So therefore I2 will be, take that 16 over there into half square, which is nothing but 16 by 4, which is nothing but 4. Hence the correct answer to this question is going to be 4 milliamperes, which is option A. Very good. Very good. Is that clear, my warriors? Okay. So beautiful question. A lot of unnecessary information. This Not needed. Why is this not needed? Then this is also not needed, just given to confuse you. The only important data points were this, then this, and then this. That's all. So how intensity affects current and how distance affects intensity was the play over here. That's the concept over here. Okay, moving on to the next one coming up on your screen. Let's see this question. In the following atoms and molecules, the transition from 2 to 1, the spectral line of minimum wavelength will be produced by which of the following elements? There is only one element which will be producing the minimum, the minimum wavelength. How inversely proportional to Arnav? That is from the light chapter. So if you remember from the light waves chapter and sound waves and all those chapters, whenever you have a point source, then remember the energy gets distributed on a sphere and the area of a sphere is 4 pi r square. So that's why you will see that the intensity is inversely proportional to r square. When you have a line source or a cylindrical source, it is inversely proportional to r. And when you have a planar source, it is just constant. So it comes from that particular chapter, Arnav Sadani. Is that clear? Okay. So that comes from that light waves and sound. A lot of you are saying A. Guys, I think you guys are wrong about this. See, you guys made a silly mistake. See, the formula that you have to use is 1 by lambda is rz square into 1 by n1 square minus 1 by n2 square. This is the formula. Correct? Now, this and this is fixed. That means n1 and n2 is fixed. You cannot change that. R is also fixed. You cannot change. R is a Rydberg's constant. Now, the only thing you can change is Z. Question says minimum wavelength. Minimum wavelength means lambda should be less. Lambda should be less. That means the ratio should be more. The ratio should be more. LHS should be more. RHS should be more. So how do you make the RHS more? By increasing the value of Z. Hydrogen, Z is 1. Deuterium, Z is 1. Helium, 2. Lithium, it's nothing but 3. So hence the answer is D. I hope this is clear. Yes, modern physics is scoring. In fact, the entire physics, I would say modern physics, light waves or general waves and oscillations scoring. And you will also see fluids is scoring, thermo is also scoring. These are scoring things. Okay, so the answer is basically lithium. There is Z in the formula. Many people forget that Z. Understood? Understood? Oh, let's move on to the next question. As per the Bohr's model, minimum energy in electron volt required to remove an electron from the ground state of a doubly ionized lithium atom. So these are basically your questions on the Bohr's model question, Bohr's model of atom. So using the Bohr's postulates, you would have derived radius, energy, velocity, etc. all those things. So just based on that, this question has been framed. Think about it. So when you take out an electron from the ground state of a doubly ionized lithium, so doubly ionized is needed so that it is hydrogen-like. So you can use Bohr's model, and we know that energy is given by minus Z square and 13.6, okay, divided by n square electron volt. This is the energy of an electron. This is the energy of an electron. But to remove it, you do not need this minus sign. So the energy required to remove it is just the plus value of it. So it will be plus Z square 13.6 by n square electron volt. So just have to substitute the values, guys. So what is the value of Z? It's a lithium, so it will be 3, and 13.6 comes as it is. The value of n is given from ground state. The ground state means n is equal to 1. So this is 1, and 3 square is nothing but 9. So 9 into 13.6. You don't even have to do the value calculations. 13 nines are, come on guys, 117. It has to be more than 117. So it has to be 122.4. Just check this out. A lot of students waste time in the calculations. See, when you see that it is 13.6, 13 nines are, you know that, 13 nines are 119, correct? How many of you did it this way? If it is 13 nines are 117, so answer will be more than 117. There is only one option like that. Even if there was one more option, let's say this was not this, let's say it was, I don't know, maybe 134 or something, example, you will not mark that because you know the answer can't be 134. because 39s are only, 117. It can't be more than 130, of course. Got it? Got it? Everybody clear? Everybody clear? Okay. Shivani, please watch my formula session. Were you there at the start? Were you there at the start? I showed you where is my formula session. I have given tricks for all the chapters, all the formulas, how to remember them by correlating with different chapters. Okay. So tomorrow is basically the EMSAT mock test. Yes, for all the EMSAT students. Answer is 122.4. Moving on to the next one. Hi Sonalika. Hello Shri Shruti. Arnav, it's practice, nothing else. Okay. Even if you practice, you will get it. Okay. And that is what I make my students do. Right now I'm teaching, all the batches, be it 11th, 12th or whatever. So I'm telling them only one thing, just practice. And I'm making them do lots and lots of problems and they are seeing the difference in their marks. That's all. That's the key, nothing else. If an electron in hydrogen atom jumps from 3 to 2, it emits a photons of wavelength lambda. When it jumps from 4 to 3, the wavelength will be how much? Okay. So let's see. I think I'll have to use 1 by lambda is equal to Rz square 1 by n1 square minus 1 by n2 square. So using this formula, I think I can get the answer because n1, n2 is given, lambda's value is asked. So if I do lambda 2 by lambda 1, okay, lambda 2 by lambda 1, the original lambda was lambda. So what I will have, things will be inversely proportional, right? So for lambda, I have to see on the top, for lambda 2, things will be there here. It's inversely proportional. Be careful about it. Okay. So lambda is below, this thing is up. So keep that in mind. So for lambda, when the initial wavelength is obtained, it jumps from 3 to 2. So it jumps from 3 to 2. So 1 by nothing but 3 square minus 2 square. Similarly, for the second jump, it is from 4 to 3. So 1 by 4 square minus 3 square. That's it. So basically lambda 2 will be, take the lambda on the other side. I think this I can write it as 1 by 9 minus 1 by 4. This whole thing divided by 1 by 16 minus 1 by 9. Okay, I think this is smaller number minus bigger number. So I can flip it also. That will be better. So lambda 2 will be lambda into, so I can just write it as 1 by 4 minus 1 by 9 because bigger minus smaller will be always better, and 1 by 9 minus 1 by 16. Now take the LCM and do the math. That's it. So this will be nothing but 9 minus 4 divided by 4 into 9, whole thing upon, and this will be 16 minus 9 into 16 into 9. So therefore it will be 9 minus 4 is 5. 9 into 4, just keep it as it is, into 16 minus 9 is 7. 16 into 9, keep it as it is over here. I did so because I thought many things will get cancelled, and they are actually. This 9 and this 9 gets cancelled. This 4 and 16 goes with this 4. So this will be 5 4s are 20. So 20 lambda by 7. That should be the answer, which is option C. Check this out. Yep, it is. Doubly ionized means Z is equal to, Gokul Krishna, thank God you asked it. Thank God you asked it. My God. So where is it? This one. So doubly ionized means what? See, understand why they give singly ionized, doubly ionized, etc. In a hydrogen atom, you have one positive charge and one electron, correct? This is your hydrogen atom, correct? In helium, you have two positive charges, two neutrons, so they are neutral. And then you have two electrons revolving in that orbit, correct? So one negative charge here and another negative charge here. But Bohr's model is applicable only when there is a single electron in the orbit. So this will become He+, singly ionized. Why do you use singly ionized? Because it is having only one electron, okay? In lithium, you will have three positive charges. Neutrons do not matter, okay? They are chargeless entities. So you should have a single electron for it to behave like a Bohr's model. So that's why Li++. If the other electrons are present, they will affect the orbit. You will not be able to apply Bohr's model. Is that clear? Thank you, Dream Chaser. That's understood. Good evening, Rihan. Nice to see you back, guys. Okay. So Arnav, if you have not practiced Tattva PYQs, you should do that right now. I mean, not level 1 now, you should go to PYQs, level 2 questions. Fair enough, everybody with me on this, understood what is the difference between them? A lot of students have that confusion. Okay, let's do this. Ionization energy of the electron in hydrogen atom in its ground state is this much. Standard value, 13.6, correct. Energy, to ionize a hydrogen atom, you need to give it 13.6 electron volts, which is standard. The atoms are excited to some higher energy level so that they emit 6 wavelengths. So they go up and they give 6 wavelengths. Maximum wavelength emitted radiation corresponds to which transition? Okay, let's do this question now. First of all, see, when you excite the atoms so that 6 wavelengths come, where will it exactly get excited? Try to think about that first. So n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. So these are the orbits. This is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. If you excite them, what all different wavelengths can come in? Well, let's see. You can go from here to here. You can go from here to here. You can also jump from here to here. All right. Well, you can also jump from here to here. You can also jump from here to here. Great. You can also jump from here to here and then here to here. So let's see. Count them. 1, 2, 3, 4, 5, 6. Very good. So this is what I wanted. 6 wavelengths. 6 wavelengths. Meaning if you have an electron in the ground state and you make it jump into n is equal to 4, then it can jump from this to this in one of these 6 ways. 6 ways. So there are so many such atoms. There are so many such atoms. Correct, guys? So each atom will have many different random transitions. Some atom it will go from here to here. Some atom it will go from here to here and then here to here and then here to here. Some atom it will go from here to here and then here to here. So many wavelengths will come. But at the max you will get 6 wavelengths. Everybody clear? In fact, you can get this from NC2, or basically n into n minus 1 divided by 2 is basically 6. So what is the value of n? The value of n will come out to be 4. You can see that right from here. If you put 4, 4 minus 1 is 3, 4 3s are 12, 12 by 2 is 6. So n is 4, correct? Now think about this. Out of all the 6 wavelengths, which wavelength has the emitted radiation corresponds to the transition? Maximum wavelength. Maximum wavelength. Where do you think you will get maximum wavelength? Max wavelength, guys, come on, think about it. Energy of a photon is given by hc by lambda. So when you want maximum wavelength, you will take the energy to be as less as possible. Energy to be as less as possible. So where is the energy as less as possible? I think it is here. This is the least energy difference. So from 4 to 3 should be the answer, which is option D, of course. Hello, Ria Bursay, welcome. And that is it, 4 to 3. So this is how you have to solve the question. I'm so glad change my prefix Mr. to Doctor. Wow, very good. I'm pretty sure you will become a doctor very soon, Bacha. Awesome, awesome. I like that confidence in you. Very good. Okay? So beautiful question on multiple concepts combined together in the same thing. Remember, whenever you draw the lines, do not make the mistake of drawing them equally spaced. See, the first gap is large, then it becomes small, small, small. So when you draw the gaps only smaller as you go up, then it becomes easier to understand, oh, where is the energy less, where is the energy more. Many questions come like this. Very good. Wow. So we have completed atoms, photoelectric effect, and photons and de Broglie wavelength. So let's move on to the next part, nucleus. Ready? So let me ask you some basic questions and then we will go to some problems. Ready, guys? Ready? Put some fire in the chat box if you're ready. I'm going to ask you some really fiery questions. First question. What is the meaning of isotones? What's the meaning of isotones? What is the peculiarity of isotones? Come on, put it up in the chat box. What's the meaning of isotones? Come on, my Bajraus, Mastanis, all my lovely warriors. Come on, do it. What is isotones? You know isotopes. Isotopes means they have same chemical properties, but they have different atomic mass number. Okay, so isotones is tone, N, N. What is rhyming with N? Same number of neutrons. So hence the answer is neutrons. They have same number of neutrons. Very good. Now tell me one thing. When you write, okay, the energy produced or absorbed when a mass is destroyed or created, then the energy value is given as something into the mass destroyed mega electron volt. What is that something? The energy which is released or absorbed when a mass is destroyed or created is given as the mass destroyed into something mega electron volt. What is that something? Come on. Very good, guys. Very good. Hope, SRTs, Ghost Rider, Samia, Mohammad, Shivani, G. Shruti. Very good. Very good, Yamini. Very good, Kirtika, Shivani, Kamal. Very good, Bhargavi, Balamukundam, Raj, Jyoti, Gokul, Jilela. Very good, Dhanush, Rajat, Kritika. Very good. 931. Correcto. It is 931. 931 mega electron volts into mass defect gives you the energy difference. Very good. Now, can you tell me the formula for average life of a decay of a radioactive sample? What is the formula? The average life of a decay of a radioactive sample. What is it? What's the formula, guys? Try to recollect it. Come on, think about it. What's the average life formula for a radioactive sample to decay? Try to think, recollect. What's the average life? Half-life is log 2 by lambda. Average life is 1 by lambda. Average life is 1 by lambda. Correct. Okay, so there is a small difference over there. Be careful. What's the value of log 2? This is going to be very useful. What's the value of log 2? Okay, very good. Already somebody has written it. Very good, Rohit. Rohit, no, but you get the wrong answer for the previous one. Jyoti, 0.693 by T half that's for half-life. Okay, for average life, it's just 1 by lambda. There is no log 2. Yep. So the value of log 2 is 0.693. Good. Keep all these values in mind. Okay, let's see if you can do this. Out of alpha particle, beta particle and gamma particles, alpha, beta and gamma, which has the highest ionization power, which can ionize the gas very easily? Out of alpha, out of beta and gamma, which of them can ionize the gases very easily? Come on, think and answer. Ionize the gases. That means when they hit the gas molecules, they knock out the electrons very easily. Yes, Kamal Vlogs, why not? Ooh. No, Jilela, you're getting it wrong. 0.30, that is log of 10. Log of 10 is 2.303. That is different. Alpha particles, guys. Yep, it's the alpha particles. Very good. And which one of them is the fastest? Out of alpha, beta and gamma? Gamma is the fastest. It travels at the speed of light. Then comes beta and then comes alpha. Alpha is bulky, big fat elephant. It goes like this, doom, 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 doom. Okay, so it is big, fat, bulky. It is very slow. Gamma is tiny, zzz, like one ant-man it will go off. But these bulky elephants, alpha particles, when they hit the gas, they ionize it because it's like elephants knocking out gas molecules. So they have very good ionizing power. Okay, great. So let's move on to some questions coming up on your screen. Here it is. The energy released per fission of a uranium is this much. A reactor uses this as a fuel to produce 1000 kilowatt power. The number of nuclei which are undergoing fission per second is how much? Standard question, very popular question. From the past question, can you tell me what lambda was? I don't know which question was that at. This one? That lambda was the wavelength of that light, which was asked, wavelength of the photon. Okay, let's do this. First of all, here this fuel is being used to produce this much power, and this uranium atom produces this much energy for one fission. So question is, how many nuclei are undergoing that nuclear fission? So guys, here is what I will do. The power is nothing but energy per unit time. Now the energy as such is the energy per fission which will be produced into the number of fissions, the whole thing divided by time, of course. This whole thing divided by time. Number of fissions per unit time is exactly what is asked. So the number of fissions per unit time will be, take this guy below the power, so it will be nothing but the power upon the energy of the fission. That's it. Now you just have to substitute the values. What's the power? The power is 1000 kilowatt. So 1000 into kilo is 10 to the power 3. The whole thing divided by the energy of the fission is 200. So 200 mega means 10 to the power 6. Electron means 1.6 into 10 to the power minus 19. This will be in joules. Now do the math, you will get the answer. Well, 10 to the power 6, 10 to the power 3, 10 to the power 3 cancels. So you will just have 1 by, and I will have 200 into 1.6 into 10 to the power minus 19. That's all. Bring this on the top. But before that, 200 into 10 to the power minus 19 is 10 to the power minus 17. So it will become 10 to the power 17 into 2 into 1.6. So this is nothing but 10 to the power 17 upon 3.2. So just do the math. I think it will come out to be, obviously, you don't even have to solve it. Will you solve it? No, right? Because it's obviously going to be close to this value. Why will it be option D, guys? It will be option C, obviously. Obviously, it will come out to be point something. So skip the decimal and adjust the powers. It will be, obviously 3 into 10 to the power 16. Actually, before doing that, it will be 0.3 into 10 to the power 17. That's all. Is that understood? Can I take the risk for second? Anurag, I think you should not. Watch my semiconductor class. It's just going to cost you 3 hours. You have 3 hours. Do that, no? Why do you want to do that? Okay. So let's move on to the next question coming up on your screen. The ratio of the radii of the nuclei, this and this, is approximately how much? The ratio of the nuclei is how much? Is radius somehow related to some parameter of the nucleus? I think so. If you recollect the properties of a nucleus, you'll remember neutrons and protons together make up a nucleus, and the volume which they occupy, the radius of that nucleus is somehow related to the total number of nucleons present inside. So now think about it. Okay. I was asking ln2, not log to the base 10. Generally, when we ask log, na bacha, jilela, then we are talking about ln, not log to the base 10. ln. Okay, cool. So here is what we are going to do over here. The ratio of the radii of these nucleus. Remember, radius is a constant into a raised to 1 by 3. A is the atomic mass number. So R1 by R2 will be A1 by A2 whole raised to 1 by 3. So A1, this is atomic mass number. This is also atomic mass number. So it will be 27 by 125 whole raised to 1 by 3. 27's cube root is 3. 125's cube root is 5. Correct? So that's the answer. 3:5. Now you might get the shock of your life. You'll be like, sir, 3:5 is not there. Guys, read carefully. You will see, no, it's not this. It's not 13:52. Guys, 3:5 is this one. Because 6:10 is obviously 3:5, right? So sometimes they might confuse you like that. Okay, I hope this is clear. All right, awesomeness. Very good. Okay, let's move on to the next one. Very good, Samiha. Moving on to the next question coming up on your screen. Fission of a nuclei is possible because the binding energy per nucleon in them is. Now this is a theory-based question. If you recollect binding energy per nucleon versus the nucleon graph, you will remember where does it become maximum? Why do you think fission occurs? Why do you think fusion occurs? Come on. Oh, Hope already got shocked. Yeah. It happens. Even when I was seeing the question, I was like, oh my god, where is this? Okay, come on guys. Gokul Logic YT, yes, you're a little bit late, but you can watch the replay later on. Anurag, it comes because the density is constant. Okay, because density is constant, obviously, because protons and neutrons are the same. So using that, you can get that the radius is directly proportional to cube root of A. Okay, B, is it? Let's have a look if you guys are correct or wrong. The answer is B. Very good, guys, very good. So the logic over here is, if you draw the graph of binding energy per nucleon versus nucleon, this is very important graph. You would have seen it goes like this and goes like that. Here these particles combine together to fuse. So they fuse to become here, to come over here, and these particles undergo fission to reach here. Remember, these are the elements which are very, very stable. More energy per nucleon, stability is higher. So this graph is actually stability versus the atomic mass number. So these are very stable. So that's why they come over here to become more stable. So fission is possible because these elements have less binding energy at higher mass number. That's why the answer is option B. These elements have less energy, so they want to get more energy by breaking and coming to a lower atomic mass number to increase their binding energy per nucleon. Hence the answer is B. Yes, iron and all these things are very stable. Iron, lead, these elements come in that stable range. Okay, moving on to the next question on your screen. Okay, a beautiful question on carbon dating. Right? See, one carbon can date, but the students are like, sir, we don't have a date, sir. Carbon has a date. So lucky, right? Look at this carbon. Okay, Alex, you need to always, understand the graphs. You can never by heart graphs. You should understand. Oh, it's becoming stable here. It's inversely proportional. Oh, it's directly proportional. Why is it going up? Why is it going down? Why is it curved? Why is it not a straight line? So when you ask questions, you will remember the graph, not otherwise. EM set is for all the the Telangana and the Andhra students. They give EM set exams. Okay, so in this sample, the carbon atom has 10 decays per gram, and in the fresh sample it is 14.14. If the half-life is given, what do you think the age of the sample is? So guys, the concept over here is every living being, okay, all these like animals, trees, etc., they have a radioactive element, which is the C14 isotope, which is radioactive. In a living organism, that amount is a fixed amount. So you know that these are the number. This is the amount of activity which will be there in a fresh or a living organism. But the moment you die or some organism dies, then the amount of reproduction of that radioactive element goes off. So we will see slowly it will decay and it will reduce. By noting down the original and the current activity, you can find out what is the time before which, what is the time of death, or from this time till behind, how much time has elapsed from the living organism whenever it was alive. So what you're going to do is, the formula that you're going to follow is, the activity now is the original activity into e to the power minus lambda t. The current activity is 10. The current activity is 10. The original activity was 14.14. E raised to minus lambda t will come over here. Bring this guy over here. So you will get e to the power lambda t is 14.14 divided by 10. 14.14 divided by 10 is 1.414, which is nothing but root of 2. Correct? That's the standard value. Now take log on both sides. So you will get lambda t is nothing but log of root 2. Now lambda I don't know because half-life is given. So how do we convert lambda into half-life? So it's nothing but log of 2 divided by your half-life into t is equal to root 2 is 2 raised to half. So it will be half log of 2. right? Let's move on and see what happens next. Okay, log 2 cancels. T by half-life is given to be 5700 is equal to nothing but half. So T is nothing but 5700 divided by 2, guys. So that's going to be 2850, right? It's going to be 2850. That's option C. There we go. Awesome. Great. Yes, Gokul Logical, I am aware of it, but that's not for all the courses. That's only for some specific courses. Be careful. Okay. So you need to know about what and all are the conditions for that. Yep. Is that clear? Can we move ahead to the next one, guys? Yep. Let's move on. First question. Okay. Sorry. The next question coming up on your screen. The nuclear reaction, this to this to this, the values of A and Z are. Yes, Hasini, it is useful for JE. Is what? What is the value of A and Z? Look at the reaction. Alpha particle is coming out. What do you think is the value of, what is the value of A and Z? It's very, very easy. Okay. Ria, you can probably browse through it. I mean, it's there over the internet also. Just go through it. IIT Madras courses without JE. If you search, no, you will get it. Or you can just leave a comment. I will let you know what are those things. You can also ping me on Captain_Shreyas. Sujita, 115 session 2 is very easy. Bacha, 50 marks per subject. Okay, that's around 12 to 13 questions, correct? You can easily get it. Just, do those topics which I'm teaching in the blocks. That's all. Okay. What is the meaning of non-zero velocities? Means velocity is not zero. It is not stopping. That's all. Second option, sure, very good. Let's see whether you guys are correct. Perfecto. So whenever you have these kind of reactions, remember the subscript and the superscript both should have balance on the left hand side and the RHS. So if it is TH, alpha particle will have 4 over here and 2 here. So 238 minus 4 is nothing but 234, and 92 minus 2 is nothing but 90. So that's the answer. Very good. Awesome. Moving on. The rate of radioactive disintegration at an instant of some sample of half-life this much second is 10 to the power 10 per second. The number of radioactive atoms in that sample at that instant is. See what is given, see what is asked. Rate of radioactive decay is given. Half-life is also given. Number of atoms present in that sample is how much? Let's see. Okay, come on my warriors, figure this out. Figure this out. What is given, what is asked? Try to think. It's just the way it has been framed looks confusing, but it is not. Okay, so all you need to work on is what is given. So like I can see, half-life is nothing but 2.2 into 10 to the power 9. Then the rate of disintegration, that means activity is given, which is 10 to the power 10, which is also your dN by dt. And lastly, the number of radioactive decay in that sample. So how many radioactive elements will be there in that sample is asked. So basically our activity is lambda into n. Half-life is given, lambda isn't given. So I can just write this as log of 2 divided by half-life into n, and this is your activity. Now let's rearrange it. Therefore n is equal to, here you will have A into T half divided by, correct, A into T half divided by log of 2, which will be the value of n. Now we need to substitute it. So n will be equal to A, which is given to be 10 to the power 10, T half, which is 2.2 into 10 to the power 9, correct? And lastly, you have log of 2, which is 0.693. So if you want, you can just do this like this. It is 22 by 6.9. I just shifted the decimals, and this will be 10 to the power 19. Now 22 by 6.93. Come on guys, 6 4s are 24, or rather 7 3s are 21. It's coming out very close to 3. You can see that. And the power will be 10 to the power 19. It's coming out very close to 3. Like 6.93 is very close to 7, and 22 is very close to 21. 7 3s are 21, so it will be 3 point something into 10 to the power 19. Hence the answer will be D. Everybody clear about this? Okay. Yes, Roshni, we are going to have a EMSAT session tomorrow at 5 o'clock. EMSAT students, mock test. That's it. Okay, moving on to the next one. A radioactive nucleus undergoes spontaneous decay in this particular series of events. Z is the atomic number of the element X. The possible decay particles in the sequence. From here to here, which particle will you get? Here to here, which particle will come out? Here to here, which particle will come out in the correct sequence? Alpha, beta and beta minus. Come on, think about it. Okay. Okay. So Bobby, your solution is very simple, Bobby. Just have to do it. Every day, make sure you practice at least, 10 to 30 questions, easy level, every day. Every day. And then, after that, slowly try to solve, average level questions, at least 10 to 15, every day. And then, from the same chapter, and then go to previous year questions, at least 10 to 20 questions every day. So try to do this slowly. After, if you pick up a chapter, try to do all easy questions first, then go for average, then go for PYQs, and then slowly you can go for more advanced level questions also. Okay, that's all you need to do. But also start with solved examples first, and also go with H.C. Verma short answer questions. H.C. Verma short answer questions are very important to trigger the application of problems, and then you can go for solved examples, and then you're going to go for level 1, then level 2, then level 3 and PYQs. Okay, so let's move on. Oh my god. Okay, so basic questions general from Tattva module you can solve, from assignments you can solve. So in Vedantu we give you first assignments after every class, which is like confidence booster. Then when you solve assignments, then you can go for level 1, and then there is solved examples to go for more understanding, and then you have level 2 and then level 3 and level 4 questions. So this is how our Tattva modules are. Okay, so let's solve this. Here the value of Z is decreasing. So think about it. From X to B, what has happened? Z has become Z minus 1. So what will come out over here? Something with plus 1 over here. That has to be nothing but a beta plus particle. A beta plus particles. Now where is beta plus in here? There is only one option like that. That is option C, guys. So hence option C has to be correct. You don't even have to solve the other options. This is how you're going to do. This is how you're going to do every time. You don't have to solve for other things. It will be correct. Even if you try it out, come on. If you go from B to C, from B to C, it is Z minus 1 to Z minus 3, right? So what should you have? You should have something with plus 2. There is only one thing with plus 2 like that, and that's nothing but an alpha particle. Alpha particle has atomic number plus 2. That's all. If you go for C to D also, you will see the same thing. From C to D, Z minus 3, and here you have Z minus 2. Oh, be careful, here you will have minus 1. So that has to be none other than a beta minus particle. Electron has minus 1 as the Z value. So that's how you get beta plus, alpha and beta minus. Moving on to the next one, that's semiconductors. I can't read your name. Well, the deodorant. I am so happy that this deodorant is working. I'm definitely going to tell all my definitely going to write to the company out there that this deodorant is really great, guys. It's so powerful that even in an online class, even in a virtual environment, the smell comes from the electrons, from the electricity, and it comes via the computer screen also. It's really powerful. I'm going to definitely write it to the deodorant team, and they should definitely consider this. And I was wondering, what is the physics behind it? If the smell can be converted and somehow it is reaching you, that means the smell energy is getting converted into, the smell energy is somehow converting, the atoms are vibrating, and maybe they are triggering all the electrons around all these screens and whatever lights I have, and that electron energy is somehow getting converted into current. Now this current is getting transmitted via electromagnetic waves using the equation E is equal to Em sin kx plus minus omega t, and then it is finally reaching your computer screen. Okay, and then when it reaches your computer screen, what happens is the electrons start vibrating with the same frequency, they resonate, and then they give those kind of wavelengths into your eyes, and probably they trigger your nostrils. And when the nostrils trigger, and then they match the frequency of whatever frequency has been sent over here, that's when you understand what smell of deodorant am I wearing. Oh, so that's the logic behind it. So I hope that makes sense. Cool. Let's start with semiconductors related question. So what do we have? Semiconductors. Let me ask you some really tricky questions. First question. When you increase the temperature, of a semiconductor, the resistance will increase, decrease, or remain the same. Theory of deodorantivity. Yes, correct. So guys, think about it. When you increase the temperature of a semiconductor, the resistance will increase, decrease, or remain the same. Okay, finally he agrees. Doesn't change? Oops. No, I don't think so. When you increase the temperature, what happens? The electrons from the valence band, they start jumping higher and higher to the conduction band. Once the electrons jump because of the thermal energy, you will see the conductivity increases, the resistance goes down. It's exactly opposite of conductors. In conductors, when you increase the temperature, the resistance also goes up. Great. Whenever you draw energy band diagrams for semiconductors, usually you draw it for option A, 0 Kelvin, option B, 0 degree Celsius, option C, room temperature. When you draw energy level diagrams, the energy band gap, conduction band, valence band, etc., then usually you're drawing it for 0 Kelvin, 0 degree Celsius, or room temperature. Which one of them? Think and answer in the chat box. Okay, let's see. Why do they excite? Because of the collisions general. They collide, hit each other, and that's how the electrons get knocked out. And once they get not completely knocked out, they get that energy from the collisions, and that's how they jump to higher orbits. Yes, it's always 0 Kelvin. No, it's not room temperature. It's always at 0 Kelvin that the energy bands diagrams are drawn. At room temperature, they show the behavior of a semiconductor. So keep this in mind. A semiconductor at 0 Kelvin is actually an insulator, because all the electrons will jump back to the valence band. Only in room temperature they will actually get excited because of the thermal energy, and they start conducting. So at 0 Kelvin is what usually you show the diagrams. Next important thing, when you talk about the base current, emitter current, collector current, which current is which current plus which current? Which current is which current plus which current? Come on guys. Emitter current, base current, collector current. Which current is which current plus which current? Come on. Standard question. You should know this. Who is whom plus whom? Who is whom plus whom? Come on, think. Okay. It's a band general. It's not an orbit. It's not a line. Okay, there are set of lines general. A band is a collection of many lines. So in each line, depending on the configuration, you will have 2 or 6 or whatever, 8 electrons, but they will follow Pauli's exclusion principle. The band, the electron can be anywhere in that band. There are a lot of places in that. Emitter is collector plus base. Emitter is the largest current, collector is the second largest, and then you will see the base is the smallest one. Collector is middle, base is the smallest current. Very good guys. Now tell me this. When you do an AND operation, or let's say NAND operation on 0 on one side and 1 on the other side. NAND, come on, let's see how many of you can give this quickly. 0 NAND 1. 0 NAND 1. What's the final output? 0 NAND 1. 0 NAND 1 is what exactly? Come on guys, think carefully and let me know in the chat box. 0 NAND 1. 0 NAND. So whenever there is NAND, always split it. AND plus NAND, not. AND plus not. 0 and 1 is 0. 0 and 1 is 0. Only when both are 1 it is 1. The knot of that is 1. So hence the answer will be 1. Very good. Excellent, guys. I can see many of you have got it correct. Let's see if we can answer this. When a diode is forward bias, then which current is higher than which current? Remember, there are two kinds of current. Try to recollect. In a PN junction diode, there are two opposing currents. One current goes from P to N, other current goes from N to P. One of the two currents is higher. Which current is higher, guys? Try to recollect this. Come on, think. Which current is higher in case of a PN junction diode in forward bias? Forward bias, that means which current will go? It's basically the diffusion. It's basically the current from P to N. It's the P to N current which is higher. The N to P current, which is the opposing current, that's the drift current, is very low. So the diffusion current is higher than the drift current, and that's how it flows. Excellent. Very good. Now, let's start with some questions, guys. I have just warmed you up a little bit. Okay, just probably gave you some random questions from here and there of semiconductors. Now it's time to actually solve some questions on PN junction diodes and semiconductors and electronic devices. Let's start with it. Which statement is correct? N-type germanium is negative, P-type is positive. Both are neutral. N-type is positive, P-type is negative. N and P are negatively charged. Which one is this? P. Pandu and Natasha. Looks like Janil was there in the class. Very good. Pandu, Natasha problems. Come on, guys. Let's see how many of you can do this question. Direct theory based. N-type germanium. So when you have N-type and P-type. Okay. Zener diode is always connected in, obviously, reverse bias. It is used as a voltage regulator. It is always operated in the breakdown region. No matter what you do, once you are in the breakdown region, the voltage across Zener diode is always constant. It's always used in a reverse bias. There is also a question on Zener diode in a bit. Answer is B. Both are neutral. Guys, many students make this mistake. Very good, Anisha, you got it correct. And some of your others also, like Shivani also I can see. And who else? Sujita. Very good, Deepu. Awesome. P and N both are neutral. A lot of students get confused. See, when you have this silicon, and then you have an N-type material, a lot of people think there is an extra electron, so it is negatively charged. Wrong. When you have an N-type, like phosphorus, there is also an extra proton in the nucleus. There is an extra proton in the nucleus, so it will effectively become neutral. It will become neutral. Don't think N means negative. N means it has an extra electron which is not forming bond. These bonds are formed between 4 atoms around it. This electron has nobody to form bond with. It's a loner. It does not have any friends. So it is in a search of a friend out there. So it's a neutral thing. Same thing with, let's say you have aluminum, which is a trivalent impurity. You have silicon over here. So there is one less bond. So don't think that because of that hole, it's positive. There is also one less proton in the nucleus of aluminum. One proton less. That's why that electron is also less to make that bond. So it is a neutral atom only. It's a neutral element. Is that clear? Yes, they're always neutral. Okay. Very good, Sujita. You have gone through the one shot. Awesome. Janil, Natasha had extra electrons. N, Natasha. Pandu needed friends. He had to play the guitar. Okay. All that things. Remember. Let's move on. P-type. Electronic configuration of germanium is this much. To make it extrinsic semiconductor, a small quantity of antimony is added. What will happen to it? Jalila, it is neutral unless and until you suck away the electrons or add some holes extra into it. Like in a PN junction diode, if the electrons leave or come into that P or N type, then you will see it will become positive or negatively charged. So if it is untouched, it will remain as neutral. Okay, bacha, Jalila? Okay. Anurag, yes, GI Advanced series coming after your main second attempt and BitSat. That's in August. First week I'll be doing something for advanced. As soon as it is going. As soon as the exam is over. C type. Is the answer C? Well, it is C. Very good, guys. Gokul, Risana, awesome, awesome. Akshay Devi SR, very good. Balamukundam, Deepu, awesome, guys, awesome. Sujita. Why is the answer C? Now, antimony is actually a pentavalent impurity. You should know some of the names of the pentavalent impurities. It's all there in NCRT or even SC Verma. So because it is pentavalent impurity, that means there will be, so when you have antimony, it will have one extra electron over here, and because of that the number of electrons will be more than the holes. So number of electron concentration is higher than the hole concentration. Remember the formula, Ne into NH is equal to Ni square. This is the formula. Here Ne is more, NH is less. So in P type, holes is more, electrons is less. The product remains constant. Keep this in mind. Yes, Anurag, you can follow that, and you can also follow last year's rank booster series. That was also for advanced. Okay, last year we had done some things for, no, it was for mains, but higher levels of mains question. But I will be doing a specialized advanced series as well on the channel. Okay, in the given figure, which of the diodes has negligible leakage current in them? Which of the diodes has negligible leakage current in them? Interesting question, guys. Come on, think about it. One of them is going to have some negligible leakage current. Look at the way they have been arranged. These are all diodes with some potentials across them. So I feel that one of them is going to be in what? Reverse bias. Negligible leakage current means reverse bias. So you just have to see which one of them is in reverse bias. There's only one such option like that. Navisha, we have been on this channel for almost like 1.5 years. This is always going to be an English channel. Don't get scared, bacha, okay? So this will remain an English channel. Okay, for both JEE and NEET. Yes, the correct answer is D. You can see that right over here. This is lower potential. This is higher potential. This is 0 volt. This is negative. This is lower volt. Obviously, current can't flow like this. So this will be in reverse bias. Every other diode is going to be in forward bias. So there is a different way of twisting and asking the question. Simply they can ask reverse or forward, but they have asked it in a different way. That's all. Okay, Selva Karthik, why don't you leave a comment or just ping me on Instagram? I will definitely help you. Better ping me or better put a comment after the video ends. I'll definitely try and reply to all the comments. Moving on to the next one. The correct symbol for the Zener diode is how much? Okay. All right. Come on, guys. Think about it. In my shift, I didn't know how the concept. So, Janil, I hope now you got to know how to solve this. Okay. So just see the potentials. So always the P side should be higher. The N side should be lower. That will be forward. Exact opposite will be reverse. Erwin Schrodinger, my God, what is the probability of you getting 7K rank? Now that I know your rank, I can't predict your branch. Or can I? Okay. All right. So guys, the correct answer is obviously option A. Remember, this is Egyptian dance. Always I tell, Zener diode na is like Egyptian dance. You do this dance. Ting, 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 ting. Okay? So Zener diode dances like this, like Egyptian dance, right? This is how this Zener diode is. And so it's option A, guys. You do not put plus and minus, that's stupidity. All right. So moving on to the next one. Here it comes. In an NPN transistor, the collector current is this much. 90% of the electrons emitted reach the collector. The emitter current and the base current respectively are how much? Yes. I know Schrodinger, Janil. I know Schrodinger. But Schrodinger does not know me. Because that would be weird, no? He is dead by now. Not the student, but the original Schrodinger. That would be really scary and spooky if Erwin Schrodinger actually knew me. Oh my God, I don't want to do that. I even know Osama bin Laden. You also know Osama bin Laden. But he does not know you. Hai? Cool, let's move on. So, emitter and the base current. So, from the collector current, I think we can find the emitter current because 90% of the electrons emitted reach the collector. This is the key statement out here. So basically 90% of IE is basically IC. So 9/10 of IE is basically IC. IC is basically 10 milliamperes. So IE is basically 100 by 9 milliamperes. That's roughly, how much is it going to be? Yes, it's roughly going to be 11 milliamperes. Very good. So now IE is nothing but IB plus IC. So therefore IB will be IE, which is 11, minus IC, which is 10. So it's just going to be 1 milliamperes. So 11 and 1. There you go, option D. Okay, moving on to the next one. Okay, let's move on. Oh, is it Janil? That's scary, right? Schrodinger's equation, one of the most dreaded equation, and they give you, and they scare kids, especially in chemistry. They just give it off. And that too, you know, fresh kids, 10th standard kids who have just studied area volume. Volume of a sphere is 4 by 3 pi r cube or 4 by 3 pi r square. They're just getting to know the world. They're just, you know, crawling out of the well, and then in chemistry and obviously physics also, we are also responsible in scaring all the 10th standard kids when they come to 11th using derivatives and calculus and all of that. And then they see Schrodinger equation in atomic structure. What? I did not sign up for this. I wanted to get into IIT. I just wanted a good college. I didn't want this, right? It's scary. Look, think about those young kids out there. Okay, so let's see how to solve this question. First of all, for the given combination of gates, ABC inputs, ABC0, AB1, C0, then what are the current outputs for each of the combinations? So when all of them are 0, let's start with this first, 0, 0, 0. If this is 0, this is 0. This is OR gate. This is OR gate. 0 or 0, 0 or 0 is nothing but 0. Now this is 0, that means this is also 0. 0 and 0, 0 and 0 is 0. Not of that is 1. So hence this will be 1. So obviously A and B options are out of question. Now going to the next part where AB is 1, C is 0. This is 1, 1, this is 0. If this is 0, this is 0. Look at only the things in blue color. 1 or 1, 1 or 1 is 1. If this is 1, this is 1. 1 and 0 is 0. Not of that is again 1. Hence the correct answer is 1, 1, which is option D, of course. Let's move on. Correcto. Amazing go. Very good. Excellente, my warriors. I'm so thankful, Risana Praveen. I see so many students from so many different states. Thank you so much. I see students from Tamil Nadu, Andhra Pradesh, Maharashtra, Kerala, Karnataka. So many people from Kashmir, so many people from West Bengal. I see so many people from Gujarat. I keep seeing the statistics of the channel. There are some students from Sri Lanka, some students from Nepal, Bhutan, Bangladesh, Pakistan, some students from UAE, Dubai, Saudi Arabia. It's crazy. Malaysia, even some students from Australia, US. My God. And I'm so grateful that this channel is in English, so all the students can be reached. That's crazy. Moving on to the next one coming up on the screen. Oh my God, Himanshu, you're from my hometown. High five, acha. Okay. Himanshu, I'll tell you which is the worst book to understand semiconductors. The one which you have studied. Worst book. Worst. Worst means worst. The bestest book. The bestest book. Sorry guys for my English. Okay. The best book for semiconductors is actually H.C. Verma. So beautifully Verma ji has written that entire concept. And watch my one-shot lecture or even the Pathfinder series, whatever you want. Watch it in combination because I have followed the exact flow of Verma ji. Beautifully he has written down all the concepts. Ramana Marine, oh my God, you're American. Wow. That's nice. Oh my God, you live in Hinjawadi. Okay. Looks like your building will be seen from my building. Okay, so moving on. Oh, I did not ask you this question, but I hope you solved this. The electron concentration in an N-type is the same as the hole concentration in a P-type. The external field is applied, then the current in N-type will be higher. Why? A lot of people get confused. How is this possible, sir? See, when you have N-type, if there are equal number of electrons, okay, and then you have P-type, and there also you have equal number of holes, when you apply external field, you might say that both should have same current, sir, magnitude-wise. Magnitude-wise, they should have the same current. No, the problem is the mobility. The mobility of electrons is higher. Here, the mobility is lower. That's why the current of electrons is higher than the current of holes. Oh, by the way, the net current is always the current of electrons plus current of holes. Usually the contribution of this guy is more. The current of electrons is higher than the current of the holes. Remember this always. Very, very important. Okay. Jai Ajinkya, there is a link in the description box. Once you get your results out, make sure you attach the result copy along with your percentiles, everything, your details. You will be getting enrolled into the Ekalavya batch. That's how it is. Okay. Let's move on to the next question coming up on your screen, and here it is. Okay, moving on. Okay, let's see how many of you can do this. In the given figure, a diode is connected to an external resistance, EMF this much, barrier potential is this much, the current in the circuit will be. So basically, if you recollect the current voltage characteristics, it goes something like this. So this is basically your barrier voltage of 0.5 volts. It's roughly this much. Okay, this is current and this is voltage. So it's roughly this much for this diode. So the question is, what is the current in the circuit? Now, what this barrier voltage means, that there is already a potential difference of 0.5 volts over here. Out of that 3.5, 0.5 volts gets dropped across the diode. The remaining is dropped over here. How much is remaining? Think about it. 3.5 minus 0.5, which is 3 volts. So across the resistor, only 3 volts will be dropped. That's all. So now you can easily look at the current. By the way, it's in forward bias. So this is obviously in forward bias. So you can see that current will actually flow. So current will be 3 volts divided by the resistance. This is 100 ohms, guys. This is not watts. This is 100 ohms. That's it. So 3 by 100, which is nothing but your 30 milliamperes. This was in amperes, so it will be nothing but 30 milliamperes. That's the answer. Done. Very good. I'm pretty sure by solving these questions, you will definitely get confidence. Very good, Anirudh. See, if you just read the theory, see, in the same 1 hour, if you would have just read the theory, maybe you will be like, okay, I know this. But the moment problem comes, you will get stuck. So that's why problem solving is very important. You cannot keep reading theory. Reading theory is good till you are in school, maybe 8th, 9th standard. But after that, you need to slowly push yourself for more and more problems. You will see when you enter into engineering or medical field, life is all about solving problems. It's not about theory. Everybody knows theory, or anybody can by heart theory. So all the successful people in life are always problem solvers, right? Be it Steve Jobs, all right, be it Jeff Bezos, or be it any founder of the company, they are solving problems. What is Vedantu? What are Vedantu's founders done? They are not theoretical people, they are problem solvers. What has Vamsi sir, Pulkit sir, Anand sir done? They have solved the problems. What was the problem? The problem was education was costly. Education was limited to only few good cities, or you have to travel. You cannot sit at your home and study, right? And only good teachers are available at only certain places. You cannot choose all your teachers. These were the problems. This was a problem statement. How do you solve them? And how do you come up with a beautiful solution which will be liked and which will be enjoyable, which can create a great amount of results? How can the scores be improved? So these are how things are even in real life. That's the reason why IITians get picked up. That's the reason why good government colleges like all the aims that you see, they have very good pay packages, or they get into very good post graduation programs or good hospitals or good research programs, because they know they are problem solvers. It's not only because of the teachers or the professors out there. These are students who have qualified JEE, qualified NEET, qualified all the difficult entrance tests, so they know how to solve problems. That's what they need at the end of the day. Remember that. So let's see what's the question out here. Oh, yes, I have visited Madurai, but that was a long time back, and I love Madurai idlis, I must say. PN junction photodiode made of a band gap of this much. The minimum frequency of radiation that can be absorbed by the material is nearly. Band gap is given. So from the valence band to the conduction band, this is valence band, this is conduction band. So if you want to make an electron jump over here, so obviously some photon must strike. So this will be some energy of the photon. So the band gap energy must be the energy of the photon. So the energy band gap of that electron must be the energy of the photon. Obviously the band gap is 2 electron volt. Energy of the photon is 1240 divided by lambda. Correct? Everybody with me on this? Understanding? How do we do this? Pavitras, Tamil, Kwanjam, Tamil Terila. Okay, I don't know much. Alright, so lambda. Oh, by the way, this is also in electron volt. So lambda will be nothing but 620. This is always in nanometers. This lambda is always in nanometers. This number comes for nano. For Armstrong, it is 12400. Okay, now once you know lambda, question is frequency. Great. So we all know lambda f is equal to c. So f is equal to c by lambda. So it is 3 into 10 to the power 8. The whole thing divided by 620 nano is 10 to the power minus 9. Great. So what I can do is I can just write it as 3 by 6.2 into 10 to the power 8. And I have written 6.2, so I can just write it as 10 to the power 7. So this will be 3 by 6.2 into 10 to the power. Bring that 7 on the top. 8 plus 7, that's nothing but 15. So 10 to the power 15. So 3 by 6.2 is roughly half, give or take. Give or take, it's roughly half. So it's roughly 0.5, roughly, give or take, 10 to the power 15. So this will be nothing but 5 into 10 to the power 14. That's hertz. That's option B. Okay. Awesomeness. That's option B, guys. So this is how you can do approximations and you can manipulate the results. Definitely, Himanshu. That's the reason why we have all these programs right from the beginning. Well, let me tell you, in Vedantu, even in the, now you guys are anyways coming towards the end of the, the courses. So let's say a student does not perform well. We categorize students into 6 categories or 7 categories or 8 categories. And we, based on their categories, we give them personalized content. Like, okay, you're not doing so well. Here is what you need to do. You need to cover up your basic stuff. You need to brush up on your basic fundamentals. Okay, you're doing extremely well. Very good. We'll give you more tough problems. Okay, you're doing somewhere in the average range. Okay, we'll make you practice more so that you come to the tougher level or higher level. So these things are there. So many things. I mean, it's obviously we have a lot of machine learning which goes on behind the screens, which you would never get to know. So thanks to the product team out there. Okay, there we come to an end. Now let me also give you a very important piece of information before we end the class. If you go below over here, you will see a very important link. There is a full syllabus JEE mock test, full syllabus NEET mock test. Now both these mock tests are very, very important. Just make sure you click on this link. If you're a NEET student, click on this link and you will see this is 999 rupees, 50% off from 2000 rupees. This is the last minute test series. There is a bundle of many mock tests clubbed together which many students are going to give. This will also predict where you stand and also tell you what are your weak points and how you need to work on them. Make sure you click on this. You can use my coupon code SHHPRO. You can log in. Right now when my maybe I need to log in and everything. So anyways, the link is right now over here. But if you want just the test series, this is good. If you want test series plus some more assignments and you also want some lectures, even in the last few days, we have the crash course lite. Don't go for the live version now. There is no point. I'm only telling you, don't waste money on the live course right now. okay, because hardly 1 or 2 weeks are there. Go for the light version. The reason why I'm telling you light version is because it is just for 1800 rupees, 1800 rupees. Here you get those test series plus assignments plus one shot classes plus doubt solving and also the class notes, etc. So if you want that extra thing, pay 1800 and then you go for that. Okay, go for the light version, don't go for the live version. Okay, now is no point for live. You will save a lot of money. Next thing, if you just want test series, then I told you, then you just go for this NEET test series. That's for 999 rupees. Both options are there. Go for it. It will help you a lot. You have seen so many problem solvings has boosted your confidence. It has improved your understanding of these chapters. I will see you now in the block 3. Okay, it's going to be on electromagnetic waves or maybe waves or something. So we'll come to that as well in the next lecture. So that's it from my side, guys. I hope you enjoyed the session. Smash the like button. It means a lot. Leave a comment after the session is over. And obviously share your word of mouth is very important for all of us. Thank you very much. And I hope you have hit the subscribe button as well. Bye bye. Hasta la vista. This was Captain Stress signing off. Take care.